Okay. Now students, this is a of frequency and this is phase cross of frequency. If you see in this example, both gain cross of frequency and phase cross of frequency will be same. Whenever the gain cross of frequency and phase cross of frequency will be the same and gain margin is exactly 0 dB I can get, phase margin is exactly 0 degrees I can get, and the closed loop control system is said to be marginally stable. Okay. So this is the second case when both a magnitude plot and a phase plots are given, the problem may be of this particular type. Okay. Then if the problem is not like this, no sir, there may be another thing. The body plot is not like this, the body plot may be like this. Now this may be a magnitude plot. Now see, there may be a plot like this. This is both a magnitude plot and this is both a phase plot. Now students, you just see when magnitude of open loop transformation equal to 0 dB, then this particular frequency is called as gain crossover frequency. But I am not interested in the gain crossover frequency. Yet gain crossover frequency, I want the phase angle. Now see here, yet gain crossover frequency, what is the phase angle? Now, yet gain crossover frequency, then if you see, at gain crossover frequency, the phase angle is, this is the gain crossover frequency because magnitude is 0 dB, yet 0 dB, the phase angle is minus 250 degrees. Yet gain crossover frequency, the phase angle is minus 250 degrees. Therefore, what is the phase margin? Now the phase margin is, now this is negative value or not? Now this is 180 degrees. Now this is a minus 250 degrees. Therefore, this is minus 70 degrees. Am I right or not? Now see here, and similarly, what is the phase margin? Now this is the phase margin. But what is the gain margin? Gain margin means I want minus 180 degrees line reference. Now this is minus 180 degrees. Phase angle equal to minus 180 degrees. This particular frequency is called as phase crossover frequency. Yet phase crossover frequency, what is the magnitude? Yet phase crossover frequency, what is the magnitude? Now see here, that phase crossover frequency, the magnitude is, yet phase crossover frequency, the magnitude is how much? Now if you observe here, now this is a gain in terms of dB, yet phase crossover frequency, the magnitude is plus 10 dB, but reciprocal means minus. Then what is the answer? Therefore, the gain margin which is equal to minus 10 dB. But what you observe here, gain margin is negative, gain margin is negative, phase margin is negative. Therefore, the closed loop control system is unstable. If the gain margin is negative, phase margin is negative, closed loop control system is unstable. Not only that, but is also you observe here the relations between a gain crossover frequency, phase crossover frequency. Now this is 0 to infinity, this is omega GC, 0 to infinity, this is omega PC. Now what is the relation? Now this is PC, this is GC. Now gain crossover frequency is, now the gain crossover frequency is greater than phase crossover frequency. If the gain crossover frequency is greater than phase crossover frequency, closed loop control system is unstable. Students, these are the very important point. Okay. So whenever the magnitude plot is given, whenever the phase plot is given, now in phase plot, the reference angle is minus 180 degrees. In minus 180 degrees line, you extend it to the plot. It will touch at a particular point on the magnitude. That magnitude reciprocal. Now this is minus 180 degrees. Now at minus 180 degrees is the phase angle. Then that particular frequency is called as phase cross of frequency. This phase cross of frequency you extended the plot in the magnitude plot, it will touch at a particular point. This is the magnitude. Reciprocal of that is nothing but the gain margin. But what is the phase margin? The phase margin is nothing but magnitude is 0 dB. Now this is 0 dB line. Now 0 dB line, this is a gain cross of frequency. Now the 0 dB line is a gain cross of frequency. Yet gain cross of frequency, I want the phase angle. Now 180 degrees plus angle of open loop transfunction at that particular gain cross of frequency is nothing but the phase margin. Okay. Now this is the gain margin and this is the phase margin. Then the closed loop control system is stable, unstable, margin stable. And the relation between gain cross of frequency and phase cross of frequency, if it is greater than, if it is less than, if equal to 0. Okay. So this is the relation between closed loop control system and open loop control system. All these are the Bode plots, Bode magnitude plot, Bode phase plot. But from this Bode plot, which is the frequency response of the open loop transfunction, you are finding the stability of closed loop control system. Okay. Now this is the way you find the stability of the closed loop control system from the open loop transfer function. Okay. Now students, this is very important. Now he is given Bode plots. Now open loop transfunction to Bode plot, diagram, open loop transfunction, Bode plot is given, you find the transfunction is given, you draw the Bode plot. That is one combination. And the second combination is nothing but he is giving the Bode plot and he is asking to find the stability of a closed loop control system. This is very important rather than all the diagram drawing and reverse or Bode plot and inverse Bode plot and original Bode plot. Now that is important and rather than this is also very important. Okay. Just note down this and how to find the stability of the closed loop control system from the Bode plots. These are the three cases you can easily understand. Okay. Note down.